Hey guys, welcome back to General Chemistry. We're going to continue our trek through talking about chemical bonds and chemical naming. Up until this point, we have talked about the main group elements, so the ones that are predictable, that follow the rules. The next two videos are going to be about the exceptions to the rule. So the first exception to the rule that we're going to talk about are those transition metals. So those D block elements, the guys in the middle, that always march to the beat of their own drum anyway. So let's take a look at these transition metals. So the first thing that we notice here in this middle area is that some of these guys can form two different types of ions, right? So we've got chromium over here that can do a +2, a +3. We've got nickel that can do a +2, +3 as well. We've got gold down here that can do a +1 or a +3. While there is an explanation for these charges, that is well beyond the things that we know. So we're going to have to be able to predict what the charge is on these transition metals using only the skills that we have, the information that we know. So when we write the name for a transition metal or we read the name for a transition metal, there's got to be a little something extra so that we, the viewer, know what the charge is on that transition metal, or we have to put something out there so that when somebody views our work, they know what the transition metal is. The way that we do that in chemistry is with Roman numerals. So here, we see those chromium ions, so it can form a +2 or a +3. We saw that on the previous slide. When we write this name in a chemical formula, we are going to write out the name. Then we are going to put the charge in parentheses out to the side. So if the charge on chromium is a +2, we'd put a Roman numeral 2 on the outside. Like down here with tin, if the charge is a +4, we put the Roman numeral 4 out to the side. So we literally tell the viewer what the charge is on that transition metal. So here's how we name our transition metals. Let's focus first on the blue box and the green box. So the blue box and the green box are exactly the same that we saw before. So blue box is name of the metal. We just write it down. We don't change it. The green box, we take the base name of the non-metal and we add IDE. Nothing different there either. Oxide, chloride, fluoride, that's all going to be the same. The only difference is this yellow box in the middle. So the yellow box in the middle tells us that we need to write the charge of the metal as a Roman numeral. Okay, so let's walk through a couple examples. Up at the top of the screen, I have two samples of copper and chlorine. Both of these formulas are true. Both of these formulas exist. They are actual chemical compounds. But they're going to have slightly different names. Okay? So let's start with the first one. So to name this first guy here. To name this first guy here, we are going to take first the name of the metal. So I'm going to write down the name of the metal. Copper. Then I'm going to write the base name of the nonmetal and add IDE. So that's chlorine. So I'm going to write chloride. Okay. So far the same. I recognize that copper is a transition metal. How did I recognize that? I recognize it because it's going to be somewhere in this area. Okay. So copper is right there in the transition metals. So that's how I recognized it. That tells me I have to put a Roman numeral. Okay. Well, what is the charge on that copper ion? It can change. We don't know. Well, we have to use the formula that's given to us to deduce what that charge should be. So chlorine is one of our main group elements. It is always going to have the same charge no matter what. There's never an exception to the rule here. So chlorine is always going to have a -1 charge. So if this formula is electrically neutral, and it is, I'm telling you that it is, if this formula is electrically neutral, What must the charge be on that copper ion to balance out the chlorine? Yeah, it's got to be a +1. Okay, so we've got a +1 from the copper, a -1 from the chlorine. That would be a neutral charge. So here's where I need to tell the viewer, I know based on the formula that this is a +1 charge. And the way that we would read this is copper 1 chloride. Okay. Let's look at this other guy over here. We're going to go through the same process. I'm going to do it in blue just to mix it up. All right, so we're going to write the name of the metal. So again, we've got copper. We're going to write the name of our non-metal, base name plus IDE. So we're going to have chloride. And again, I left a gap in the middle because I know I'm going to need to put Roman numerals in there. Now, if I look at this one. So again, we're going to start with chlorine. So chlorine is a main group element. It's always going to have the same charge, and that charge is going to be a -1. But what's the difference with this guy? Yep, there's 2 chlorines. So if we think about what chlorine brings to the table, it's got 2 of those atoms. Both of them bring a -1 charge. So altogether, it brings a -2 charge to the table. Now go over to the other side for copper. I've only got 1 atom of copper on this side. So that 1 atom of copper is going to have to balance out or take care of that -2 charge. So what must the charge be on this 1 atom of copper? Yeah, he's got to have a +2 charge. Okay, so +2 from the copper, -2 from the chlorines. That's electrically neutral. So for this one, we would write Roman numeral 2 in parentheses. And we would read this copper 2 chloride. Okay, that's what we see here. So going back the other way is always pretty simple. If you ever see a Roman numeral, you should be like, woohoo, I don't have to think. If there's a Roman numeral written somewhere, it's literally telling you the charge on that particular ion. So you're not going to have to go and search and think about it. So if I saw this formula right here, I would say, okay, copper is my metal and its charge is +2. I don't have to look anywhere else. Okay. The last thing that I want to just mention while we're in this slideshow is, get all this mess off, is a couple exceptions to the exception. Are these guys down here? So tin and lead are technically situated in the main group elements, but we treat them like transition metals. So for tin and lead, they will require a Roman numeral. How are you going to remember that? They're in the P block. That's not going to jump off the paper. Well, here's the silly way that I remember it. They're weird anyway. They're weird to begin with. So the chemical name is tin, and the symbol is SN. It doesn't make any sense. And for lead, the chemical name is lead, and the symbol is PB. It's weird. That doesn't make any sense. So let's go ahead and lump them with the weird guys, and they are exceptions to the rule. So if I were to write the chemical name for one of these compounds, I would write something like tin 2 and then the nonmetal. So those two both need Roman numerals. I hope you guys found that helpful. That is it.